So for those of you who don't know, Airflow is a Python-based open source software, which allows you to automate a lot of your jobs and do task scheduling. So if you have a lot of tasks that say, let's say you want to do post-processing after your training is done, or you want to do pre-processing before all the other stages are applied. So that's where you want to do Airflow. So it allows you to kind of order your sequences and like have your jobs run in a sequence based on the rules you mentioned. And since most of you may not be familiar with Airflow, I'm going to keep this one very hands-on and very basic and on the beginner level so that we can all follow and learn along. But if you have any questions or more advanced kind of discussions, feel free to bring it up to me and I can answer that. No, actually, I'm just going to start the presentation.
Done very well.
Thank you. So here it is. So right now I'm working with a blank slate, basically. Yes. So yeah, I've set up a blank slate here. Basically, I have nothing here. I just went to the Airflow GitHub repository, and I said I want to set up a simple server. And then they give you a bunch of options, and I set them up using Docker Compose. If you're not familiar with Docker, you don't need to worry about it. Basically, all it does is that it sets up your environment, and it allows you to run those servers on your laptop. And then the folder that I'm going to be working with is called the DAGs folder. So DAG is a short form for directed acyclic graph. And that's how you want to formulate your pipeline. So if you have a bunch of jobs that follow each other, they basically form a graph, and it has to be directed. So it doesn't need, so directed meaning that it doesn't have any loops in it. So yeah, that's the idea behind DAGs and why it's called that. But any job that you have, you define it here. And the good thing about Airflow is that everything in here is Python-based, and all you have to do is define your pipeline as a Python code and then have Airflow take care of the rest. So for example, here I created a new file, sample.py. And all I do is that I import the DAG folder, which is a special function for Airflow where it converts your code into a DAG. And then I wrote a simple function, a sample DAG, and then I decorated it with that decorator, the @DAG decorator. So this tells, sorry, what? Yeah, sure. Is this good enough or? Oh, no problem. Yeah, I think I'm having a hard time. Okay, good. So what does this DAG decorator do? It turns a simple function into a pipeline that can be run within a schedule. And so far, I have the schedule interval as none, meaning that anytime I want to run my functions, I'm going to run them manually. But this can be anything. It could be a daily job. So if you mark it as daily, it's going to run every day, beginning of the day. You can also have a lot of different custom schedules. So you can, for example, have it run on specific days if you define a Python object for that. The start dates, for now, you don't need to worry about it. It's just the day that you want your pipeline to start running. Basically, the day you expect the data to be coming in. For now, you can feel free to ignore it. I'll later explain how this can come into play. Same with catch-up. I'm going to explain it alongside the start date later. And then you can have descriptions, and then you can have tags. So tags allow you to kind of organize your tags. They don't have any functional meaning. It's just a way for you to organize all your tags. So right now, if I go to the Airflow UI, and I'm going to go to the main page, I see a sample DAG here, and then it says it's empty, no tasks found, because my DAG is a pipeline, but it doesn't have anything within it. So now I want to write some functions inside of it. So what I'm going to do is that I'm going to also import the task decorator, and then in here say, write my own function. So print, let's say print hello. And then in this function, all we do is that we print hello world, like this. And I'm going to decorate it with the task decorator. So I'm going to save my file, and let's see what happens here. So I'm going to go to the DAG, and I'm going to zoom in a little bit on this. And I'm going to refresh the page. So it still says no task found. And the reason is that it's based on a Python script. So defining a function itself is not enough, similar to how I did for the DAG. As even though I had it decorated, I had to still define an instance of that object or that function. So all I did was that I said DAG equals sample DAG. So I created an instance of it. So I'm going to do the same thing with a task. So I created this function, but now I'm going to say task1 equals task. And now I'm going to save, and I'm going to refresh the page. Probably it's going to take some time. Or wait, sorry, I had a typo here. This should be print hello. Okay, now you can see print hello appeared here. And it hasn't been run, so that's why I cannot get any information out of it. But let's go ahead and run it. So the first thing you do is that you unpause the DAG. This just basically is a safe, is a way to make sure you don't trigger DAGs by accident. For example, you have a daily job, but you pause it so that in the future it doesn't trigger by accident, things like that. So yeah, unpausing it, just make sure that you allow the DAG to be run. And now I'm going to trigger it. So if I trigger it and I refresh my page, I can see, oh, it succeeded. So I can see the logs here, for example. Yeah, it did a few things. Here, these are all information about the job, but then I see, okay, it printed the hello world here. And it succeeded. It exited with a return code 0. Okay, so that's pretty straightforward. That's pretty simple. That's something we can do with Python pretty easily. So now let's make it a little bit more interesting. So I'm gonna duplicate it and create another one. I'm gonna call it print hello 2 or whatever. And I'm gonna say hello world number 2 in here. So now I have 2 functions. Yes.
Is it important that these are scoped functions inside sample DAG?
Yes, that's a very good question. There are different ways you can define your DAGs and tasks. In this way, which Airflow calls it the task flow API, it has to be scoped within that DAG function so that Airflow knows that, hey, this task that you defined belongs to this pipeline. But there are other ways you can define it if you don't want it to be this format.
So the directed acyclic graph is being defined as a set of scoped functions.
Exactly. Exactly. And
So that's
they're
the
all.
DAG. The DAG part is what's inside that function is.
Yes, yes. The DAG is basically a graph, and the nodes are the tasks. So the nodes follow each other.
Now I got it. Thank you.
Yeah, now if I do the second example here, so I'm going to do task2 equals, print hello 2. So I created 2 tasks. So let's see how it looks here. Okay, I have another function here. So by default, Airflow wants to minimize the time it takes to run your DAG or your pipeline. So any job that it can run in parallel, it runs in parallel. So if I trigger this one, probably both of them are going to run at the same time. And it's hard to see, but I can guarantee you that this is what happens. I can simulate it even if needed. But basically, anything that you don't have a sequence for, so you don't have a requirement that this job follows that job, Airflow is going to run it in parallel. And if I refresh here, probably both of them are going to get done. I can also go to the grid view to see a better historical version of that, just to see that, okay, the first time I just ran 1 function, now I have 2, both of them succeeded. And I can see the logs here. And this one is hello world number 2. So it ran them in parallel. Now, I can run as many tasks here as I can or as I want. For example, I can do a for loop and do a lot of print hellos. So for example, for task in tasks. And then I also define tasks here, and then I say here range of 10. Let's say I define 10 functions. And then I say tasks.append prints hello. So what I do is that I create a task, or let me actually make it a little bit more readable for you. So I create a task, or current task variable and say print hello, and then I append it to the list. And now if I take a look at it, if I save and then go back here, probably also I need to rename. Let me make sure.
In your flow,
Sorry, what?
on the current task equal print below, did you mean the params there? Function invocation or the
Oh, it's a function invocation. So this here, I define my function, but anytime that I want to convert it into a component or a task, I have to create an instance of that function. So that's why it has to be like that. Okay, I have a small syntax error. Yeah, so probably here I have an error. So for I in range of 10, and then I do print hello. So I'm going to do one thing. I'm going to say, even this one is not needed. I'm going to save it one more time, see if there's any errors now. Okay, no errors. So you can see now, I created all these print hellos, and I have them all in a loop, and I can run them. So now I created a pipeline, a small, it's not even a pipeline, but a bunch of components, a bunch of functions that are all running in parallel. And you can see here that when they're light green, they're all running in parallel. I can even show it import time. And then if in the function I do time.sleep 10, so each task, I simulated it to take 10 seconds just to see how they run in parallel. So yeah, if I refresh, you can see these are running, all running at the same time, and then they're all gonna complete around the same time. So this is all good again, but this is something we can do with a lot of like parallel processing libraries. Now let's see how we can convert it into a better format of the DAG. Yeah, it's something that they change a lot, but in recent versions, if you have multiple names, they kind of add a suffix to it. But yeah, the logic changed a couple of times recently. Yes, please.
Does it matter what like the variables are, or just the variables been defined with the task decorator?
That's a very good question. Yeah, the variables here are just placeholders in a way. So they don't have any meaning in your code. The only meaning that they have is that they usually Airflow picks up the name in the component from the function. Those are the only place where your Python objects have any value. But if you save it in a variable like current task, it doesn't even matter as long as it's in a variable. So for example, even my tasks are not even stored in a variable. As long as they're kind of in the context of, yeah, the DAG, that's enough. So yeah, we can see that they all ran. So now to make it more interesting, I'm going to have names for these. And I'm going to say tasks, the tasks of I, and then I'm going to change this one I. So I'm going to do like, I think it was like this. I'm going to check that.
You have a question from chat that says, so are these tasks kind of like greenlets? I don't really know what greenlets are, but if you know what that is.
Can you repeat that? Kind of like.
Are these tasks kind of like greenlets?
I'm not familiar with.
I'm not familiar with greenlets either. So Matt C, if you'd care to explain. So
Oh, that's fine. I can. I
So
don't want to derail the
they're
conversation.
more
sorry.
than just a thread. They are run in their own process, but they're more than that because they are bound to a schedule. They're bound to a sequence. We can see later where it's not just the process itself. It's also how that process is managed. Like it waits for the previous tasks to complete before being completed. And as soon as it completes, it triggers other tasks. So it's got more meanings to it than just the process that is being run. So yeah, now let me try this. So I would say that task, or I can even make it simpler. So I have a tasks. I'm going to revert back to what it was, and I'm going to remove the sleep. So this tasks list is a list of 10 tasks, right? But now I'm going to say that the first task should always be run before the second task. And that's the syntax for it. That's as easy as it seems. I just have to fix a typo here. And now let me go back to the UI and refresh. Let me just check it one more time. Sorry about it. Probably I had a typo here. Okay, here it is. Yeah, it just took some time. So now you can see that the first task is done first and then the second one. And actually, now that I think of it, it's better if I have the time.sleep so that we can see it better. We can see better how it happens. So I'm going to trigger it one more time. And you're going to see that this hello 1 is not going to get run until this one succeeds.
So that's how you enforce a pipeline?
Yes. So that's how I enforce a sequence. I say this task, hello 1, like with the 1 suffix, shouldn't run unless the previous one has succeeded. And actually, I can do it one more time and see how it can affect it. So for example, I'm going to mark one of the tasks as soon as it starts as failed. Okay, I hope I did it fast enough. Now, this one never runs. All the other tasks are successful, but this one never runs. And the reason is that if you see the description, it says the trigger rule is that all of the previous tasks are successful, and it hasn't happened. And yeah, the good thing about the UI is that you can get a lot of information about it. So if you don't know why this one hasn't run, you just click on the task, go to instance details, and then it says was not in the running state, and then task is in the upstream failed state. Upstream is the tasks before it. Downstream is the tasks after it. So because the task before it failed, this task never got triggered. And
also join methods, et cetera, so you can wait for messages for multiple streams before you trigger a function, that sort of thing. There's a way to pass results between functions.
Yes. I'm not sure if I'm able to do a demo on that one, but it's called XCOM. So if you want to read more about it, there's a term called XCOM, which is kind of an abbreviation for inter-task communication. And then in here, you can pass the data. So let's say your first task or your second task relies on a message from the first task in order to do its job. You can use XCOMs and say the first task requires like this kind of thing. But yeah, you can.
That's how you can do all of the data flow style of merging and sequencing of multiple complex fan in, fan out.
So there's a caveat to it though. With the XCOMs, yes, there's always a trick. So Airflow is supposed to be the scheduler or like the control plane of your jobs. And even though it has the XCOM feature for passing messages between these tasks, but it's not meant for transferring large data because the database that it has is meant for metadata mostly. So what you usually have to do is that you handle your data in another framework, for example, Spark, and your like external volumes, which are meant for that kind of big data processing, but you use Airflow as a control plane. And for example, your task can contain the path to the data that your previous task created. So in here, the message passed between the two operators or like the two tasks is that where the data is stored. But the data itself is better to not be moved. And the default one, I think, is 15 megabytes for Airflow, on like the limit of the data that it can transfer between the tasks. So it's not meant for that kind of purpose. And the reason for that is that it's meant for just mainly scheduling. So this is kind of like the basic overview of it, but you can do a lot of like cool things with it. So let's say, also I would say task 1 follows task 2, and then you can just say task 3 here, like the third index or fourth index basically, also follows, let's say, the first index, something like that. So you can write as many rules as you want, and then when you get back to it, Probably there's a small delay here, but yeah, you can see that the DAG structure changes based on the rules you mentioned here. And another thing you can do is that because all of this is Pythonic, you can define this in a for loop. So for example, you can say for I in range of 5, just for the first 5, tasks I follows tasks I plus 1. So now I defined that in a for loop, and you can see how it changes now. So you can define your sequences with a Python function. And yeah, you can be pretty creative about it. Obviously, there are limitations to it. But if you want, I can talk about the limitations as well. But I think for most cases, you can write some basic Python functions and define your flow here. So yeah, that's the main kind of thing about it. And I would say this defines the flow overall. But the example that I provided on the server I have here is a local server for development. Usually, if you're working with production data or production stuff, you want to run it on a more suitable environment. And the two that are really used a lot are Kubernetes and Celery. So basically, Airflow runs these tasks in an environment called an executor. So executors are used to kind of run these tasks, and then it could be anything. So for example, the one that you have in local just creates a simple process out of it. But if you're using Kubernetes, I'm not sure how familiar you are with it, but you can create basically each task in its own isolated environment, in its own kind of virtual environment in a way, and have more isolation and more performance in some ways. And yeah, that's, I would say.
So you just said that we can actually have each of these functions in their own container, Docker container, Kubernetes managing, and the DAG system, Celery, whatever is going to schedule all of that across the Kubernetes cluster.
Yes, and that's how you achieve scalability and high availability. And also, one other thing is that each task, right now, what I showed you was a Python operator, meaning that it executed a Python code. But there are many, many operators. So for example, if you're using Kubernetes pods to run your jobs, you can use Kubernetes pod operator, which takes your code, like take your code, put it in a Docker container or a Kubernetes pod, and then you run that pod. Or it has a Docker operator where it runs your code in a Docker container. And it has Spark operators. It runs Spark queries for you and things like that. So there are many, many different operators that you can look into. So for example, if you're interested in the Spark one, you do Spark operator and then Airflow. And you can see all the different functions here. Yes, please.
Does that mean you can run just arbitrary Docker containers, just use Airflow as control plane? You can just run any sort of code like how you get Rust or something.
Exactly, and that's part of, like, that's one thing that a lot of people do, because Kubernetes scheduler, even though it's great, but it doesn't have all the timetables and all the schedules. It doesn't, by default, Kubernetes jobs allow you to kind of define a lot of things about how you want your jobs to run, but they're very basic. So with Airflow, you can have retries, and you can also have it send emails if a task fails or is retried. And then you can have tasks follow each other, and then you can do many, many, many different things that you can't do with a Kubernetes scheduler by default. Yes, please.
So for production, do you, your company, I guess don't tell me, but do you manage it all yourself, or do you use one of like type of analytics to be clear up to this point? We're usually trying to use this in real life, like that's where I'm noticing we're spending more time to build structure than just manually running the job yourself.
Yeah, that's a very good point. So if managing all of these is a challenge for you, there are companies that provide it as a service. Obviously, Astronomer is the main one. They're also contributing to the Airflow open source project a lot. I cannot go into the details, but we use a mix of cloud components and we also self-manage the Airflow instance. So we have the Airflow instance, but for a lot of like the infrastructure and stuff, we use cloud components to kind of do a lot of those different kind of functionalities for us. So it's a mix for us. It's not fully self-managed, but we don't use it as a we don't use a SaaS solution either. Yes, please. Yes, and that's a very good question. So if there's something called templates in Airflow, you can read about them if you need them. But if you want to have your jobs to be a little bit more dynamic, let's say, for example, you want to pass in inputs for your DAG anytime you want to run it. So for example, here, I can go ahead and trigger this DAG with a config. And then this could be a JSON configuration. So I can say inputs is 2. Inputs 2. So you trigger it with this. And then what happens is that it triggers that DAG and provides that as an input. And then in your jobs, you can use that input and kind of get some values out of it, for example. Or you can use that input to make your jobs more dynamic. I don't know if I have the time to go through the implementation now, but yeah, later on, if you have any questions on that, feel free to ask me. Yes, please.
In Airflow, is it possible to trace or track data or documents that might be one by their interface?
Yes, yes. So that's one of the major advantages of Airflow. You have a lot of visibility over different things. So in here in the UI, first of all, you can see a lot of metrics of when you ran your DAGs, how long they took, how many tries it took, things like that. And also, there's an audit log where anytime someone either triggers a DAG or reads the DAG or anything, any action, it's shown here. And you can always trace it. You can always see how it went. And then also in here, you can see the audit logs and task instances for all the jobs basically that you have. So yeah, in terms of tracing and having a good monitoring on the tasks themselves, all of them are provided by Airflow. And also there's an API that you can use, Airflow REST API, which you can get that information through an API. So if you want to do your own processing through pandas or anything, you can. There are a lot of APIs that you can use and get information about, for example, your task instances or your other DAG run metrics, things like that. Yeah. Any other questions, concerns? All right. Thank you so much for your time. And
Wait. Don't rush it. There are questions. We have a discussion here online about some of the things that you were saying. So Airflow, as far as I know, is part of the Spark ecosystem. It has all of this Yarn and Spark, and Airflow is one of them. If I recall correctly, and correct me if I'm wrong, it's all Java-based. Yes, it has an interface. All of those have very nice interfaces to Python. PySpark specifically, very good. But eventually, there are the Python equivalents of all of those tools. Actually, one of the Airflow people left and started the Prefect a few years ago. But there's also Dask and there are others, Ray or whatever. All of those systems that allow you to run things in parallel. What are the things you like in Airflow that you think that are very, very good that you didn't see in other libraries that have such support? I'm saying Dask, Prefect, Ray, whatever.
that's a very good question. So in terms of scope, I think Prefect is the closest to Airflow. So I'm going to first eliminate other options. So for Dask, it's mostly for parallel processing and distributed computing, but it's not meant for scheduling. So with Dask, your main goal is to just run a lot of like RAM heavy or CPU heavy functions or methods on multiple computers. And you let the Dask scheduler basically split that function on the function level to split that workload onto different machines. But Airflow is not working on the function level, and it's working on the job level. And the main goal is about timetables, scheduling, and managing all the tasks and the data that flows between them. So for example, one thing is that Airflow allows lineage. I'm not going to go through most of it, but yeah, it allows you to track your data, track the things that happen to your task, who triggered it, how to trigger it, when to trigger it, things like that, where Dask doesn't have any of those because it's working on a different scale. And actually, Airflow has a Dask executor, meaning that it uses Dask to run the function. So you can basically use both of them at the same time. Let Airflow handle the task level scheduling, and let Dask handle function level optimization and workers. So and then for Ray also the same way, works on a different scale. So it's, as far as I remember, it's for GPU like distributed training. And also I know that it also works with Airflow. So there's an Airflow Ray provider that I looked up a while ago. I haven't seen too much activity on it recently. As you can see, it's been a while, but the idea with Ray is that it's used for distributed training. So again, Airflow can handle the task level and scheduling workload. And then these libraries can work on the function level optimization and the script level optimizations. For Prefect, as you mentioned, yeah, it's a new project. It's very nice, very simple, very intuitive. I haven't worked with it too much, but as far as I know, since last time I looked, it's still new. It doesn't have the same community that Airflow has. So I'm just going to go through the GitHub of Airflow just to show it as an example. I'm pretty sure the numbers here in terms of community and in terms of like the overall contributions don't match here. So you can check the stars if you want. You can check the commits. You can check the last activity. In terms of all the metrics here, Airflow has a stronger community and it's been there for longer, so it has a lot of more features built in. Whereas in Prefect, a lot of those features weren't built in yet. But the advantage of Prefect was that it was very easy to start with, much easier than Airflow, because Airflow has different components and a lot of like details that needs to be handled, whereas with Prefect, it was way easier. So that, I would say that's the main advantage of Prefect, but I still, and that's why I still prefer Airflow in many cases.
Okay, I would suggest you look at the last version of Prefect, Prefect 2.0. They're very good mechanisms that started, the minute they started doing this, then I started saying, okay, what do you need Airflow? Check it out. It's more Pythonic, that's for sure. But that's my opinion. I might be wrong, and everyone is entitled. But thank you. You have a good, you gave a good answer. Thank you.
No problem, of course. All right.
Awesome. Let's give him another round of applause. He came all the way from Chicago. Did I mention that? I was supposed to mention that. Came all the way from Chicago for this Airflow presentation. Now, I've never used Airflow, but this is a easy design pattern that's put across a lot of different. Oh, I can't get too close to the speaker. I'm gonna. Yep, very annoying. But yeah, like if you do any CI/CD, like a lot of pipelining, it's a great design principle. If you've never played with anything like that, to go around and play with it. Will you publish that as a snippet and maybe share it? That would be cool. Love to see more snippets. We're gonna take like can we take a 10-minute bathroom break, intermission, mingle? Sound good? Jacob's got a thumbs up. Here we go. Do it. We'll come back at 8 Texas time. So I meant.
Thank you.